Hello learners, welcome to NeenvIAS. Today we are discussing in this session the PYQs of Science and Technology for CSE Mains. The topic is Space Technology. Right, so let us see the question. The question came in 2017. The question says, India has achieved remarkable successes in unmanned space missions including the Chandrayaan and Mars orbital mission, but has not ventured into the manned space missions. So the question starts here. This is the context. What are the main obstacles to launching a manned space mission, both in terms of technology and logistics? Right. So let us understand the question. Oh, of course, examine critically. So there is a tail word here attached, which is called examine critically. Now this means you analyze the positive, the negative, and the basically overall implications. The overall implications of the topic, and then because of which you will give a balanced opinion. You have to consider everything and then give a balanced opinion, right? So look at the both sides of the issues, that means the progress and what can be done in the future. So blueprint of the question, you introduce India's achievement, then you analyze the technological and logistical challenges, then you take the steps taken by the ISRO, then government steps, and then we relate with the Gaganyaan project. Now Gaganyaan project was formally launched in 2018, but news about it was going on previously in 2017 also, hence this question was asked. So please focus on the patterns of the research or new steps that are taken by significant organizations like ISRO or by government. So UPSC tends to ask something that is in development because it wants to check your opinion. So they want to see how you are conducting yourself in terms of research or in terms of knowing about things. So what is your opinion? They want to know that, right? In the introduction, we will talk about space achievements, right? Like Chandrayaan, Mars orbital mission, Mangalyaan basically, right? Which has given ISRO an elite status. Current status, India has not yet ventured into manned space mission because of technological and logistical challenges. Basic introduction, nothing much can be added. So what are the technological challenges? First is the human related or human rated launch vehicles. Basically, when you're launching humans on top of a rocket, you need a very secure system and you need rockets that can carry at least 8 tons, right? So GSLV Mark III needs to be updated and tested so that it can carry payload up to 8 tons. It needs to be human rated also. Rated means it should be safe enough for humans to travel in that rocket. Next is life support system. Let's say you have launched people safely. Now what about the breathing apparatus, or what about eating facilities and everything? So you need to develop reliable environmental control and life support systems so that people can actually survive in that environment. Now issue is we don't have any technology for this, and many countries are not willing to share this also because this is a very costly, or let's say it's a very intensive IPR issue. Next is crew escape system. Now you have launched them, now you have given them an environment, but let's say if something goes wrong, what will you do? So for that you need to design a system from which the crew can escape. So you need complex abort systems which you need to develop. Then again, this is issue is there that we don't have this system currently with us, so we have to rely on imports. Next is spacecraft design. The spacecraft should be able to come back with the astronauts safely on the Earth. Usually what happens is they have a system like this, right? And here the crew will sit, right? So such a capsule will be designed and it will drop in the ocean with parachutes. So initially this is done. After that, a proper spacecraft design which launches into the spacecraft with the rocket. So this thing will be on the rocket, but spacecraft will be developed in future, which is by India, or NASA already has it. Now in that what happens, there is a spacecraft which is attached to the rocket, right? And then it is launched into space. This is not there in that. And then it is launched into space, that it detaches, and then spacecraft goes and comes back. So spacecraft design is there, challenges is there because radiation is there in the space, all right? and then you have to protect the astronauts from exposure to radiation, right? Of course, when you are orbiting the Earth, that needs to be the orbiter which is going on around the Earth, it needs to have very specific type of avionics. That means the systems to control and navigate in space, because in space, on Earth, let's say if I throw something, it will come back like this, right? But in space, a lot of other forces are there, and if you have to go from point A to point B, let's say point A to point B, you might have to go like this or like this. You can't go like this. So such things are there in space. So a lot of advanced level of avionics are needed. Okay, and of course there is one thing in space which is docking. That means your spacecraft connects with another spacecraft. It is called docking. Now this can be between two different type of spacecraft, like NASA is sending its astronauts to International Space Station. So International Space Station is traveling like this, and then the spacecraft goes and docks over there. So when the connection technology is very crucial. If you have seen Interstellar, there is a scene in which the spacecraft explodes, in which Matt Damon is there because of the bad docking procedure. So docking procedure is extremely critical, right? Logistical challenges. See, first thing is astronaut training. Again, we don't have this facility, so we have joined forces with Russia for training, but we have plans in India to develop the training center, advanced training center for astronauts at Chalakere in Karnataka in Chitradurga district. Next is the infrastructure development, because we need launch pads. We need proper launch pads from which rockets can be launched repeatedly. And then we need mission control centers for human flight. Then space suits are needed, of course, crew support systems. Basically what happens is when you want to live for a longer time in space, you need to produce food also. So there are sometimes packages that are sent, and the food preservatives, which type of food preservatives should be there, how to digest food, things like this. International collaboration is a challenge, because many countries are not willing to transfer those technologies which they have, right? Of course, because of late entry into MTCR around 2016, we have been behind in technology also with regards to other technologies like rocket. Budget constraint is out there, of course, because India is a developing country. We have other priorities also. So Gaganyaan project, which is the manned space mission, it needs around 10,000 crores. Skilled workforce. You cannot train astronauts in one day. You cannot give them trainers which are trained in one day. So all these things take time. So this is a long-term investment. Space debris threat. In low Earth orbit, where the manned spacecraft will go, there's a bigger threat of space debris. Even a small nail, or even this much of particle traveling at 1 lakh kilometer per second, or sorry, 60,000 kilometer per second, like this. So it will travel this much only, this much, the tip of the pen only. It will this much. Okay, even if this is traveling, it can destroy the spaceship. So even such particles are tracked. Steps taken by ISRO. Now we come to the next part. See, they have created a human space flight center in 2019 for space flight projects. Training collaboration is there with Russia, the Gagarin Cosmonaut Training Center. The 4 people that have been selected, they are sent here. Technological developments are there. Progress is made in crew modules, life support system, crew escape system. There is pad abort test was there. That means the launch pad, if something goes wrong, how can you make the crew safe and bring them out? So that is a crucial test. Like in when NASA launches the spacecraft, they have a specialized tunnel for this. So the pad abort test is important, which was successfully done in 2018. Vyom Mitra. Vyom means space universe. So Vyom Mitra. This robot is developed for unmanned testing. It will go up and detect things and sense things by sensors and bring back the data. Then space capsule recovery experiment and crew module atmospheric re-entry experiment. These 2 have been successfully done, which is important for ensuring their safety, the crew's safety. Now SRE was done in 2007 and CARE test was done in 2014. This was done to develop heat resistant materials for human space travel, so that when they're going up, they will face thousands of degrees. When they come down also, then they face thousands of degrees. So we need to create heat shields and we need to test them. So that has been done already. What is the government support? Policy support is there. Full support is provided by government for this mission, right? And they have also gone for international collaborations. Budget allocation is there. Cabinet has already given 10,000 crores for Gaganyaan mission. International partnerships like with NASA, Roscosmos for technology acquisition and training. Even NASA has collaborated with the ISRO on various projects. Now we come to the Gaganyaan mission, because of which this question was asked, but that was not launched formally, but now it has been launched, so we'll discuss briefly. The objective is to send 3-member crew for 7 days and develop GSLV Mark III human rated crew module life support system. 2 unmanned spaceships will be sent, missions will be sent, and third one will be the human space flight. It will the first two will focus on testing spacecraft systems and crew safety. Next is future plans. Now this will be linked with the plan to launch India's space station by 2035 and landing on moon by 2040. So all the testing that will go on here, all the learnings that we do from this thing, the manned space mission, we will be using that in putting Indian citizen on moon by 2040, right? So India's ambition, the conclusion, India's ambition to launch a manned space mission faces significant technological and logical obstacles, yes, but many strides have been made, right? Like Gaganyaan project, like the testings, SRE testing, care testing, pad abort test that has been done, right? So ISRO aims not only to achieve the manned space flight, but also to lay the foundation for future endeavors such as Indian space station and humans to Mars and to moon. So these efforts will mark a significant leap in India's space capabilities and position the country as formidable player in global space exploration. Here I would like to bring attention to a cartoon which was made in an foreign newspaper, in which it was a bit racist towards Indian, like the Indians with cow are knocking on the door of elite space club. So now that is totally, let's say, we are laughing in their faces, right? So such things bring repute to India, such projects bring repute to India and give us a global standing in space race, right? So that is all for this question. Thank you.